G'day, Michael here. This seems to be a problem that all the printers eventually get that I buy new. They go so and so long without any trouble, and all of a sudden they fail to feed. Now this thing here, you can see it's sort of got stringy. Just basically, they seem to extrude about half as much as they should. And it's quite, it just seems to be a non-stop thing. Every time there's a new printer employed, I've got to go through the process of rectifying this problem. And it doesn't show up on the first, well, in this case it did show up on the first spool. It's probably about half a kilo in. But on many printers it takes maybe 2 or 3 kilos of printing before it actually shows. Now I run my printers a little bit hotter than usual to get some better interlayer adhesion, but then you get to this point where there's basically no interlayer adhesion. So, but what's the cause of that? Well, what I find is always the cause, well, the printers I've had, no, this is number 5 now, is you've got, this is your basic assembly, right? And what they have is you've got the small hole going down the centre for the 1.75mm filament. I think it's a 2mm hole in most of the units. And you've got this fitting here, which then accepts the feeder tube. I might just put this on a holder. Okay, so my hands are free. Now what you've got is the feeder tube from the Bowden feeder going into this fitting here. Now the feeder tube itself, where's my camera gone? There it is. The feeder tube itself is nominally 2mm inside and 4mm outside, or thereabouts. Okay, so that goes into this fitting here. And then on the other side of the fitting you've got this oddball looking hole, which is not as big as this tube. Where are we? Focus. Not as big as this tube, but it's bigger than the filament. So there's a possibility of the filament sort of buckling under pressure and bunching up. Now the next problem we have is a bit further in. This portion here, you can see how it's got that like tapered end before it goes down. Now that fitting goes into here to about that depth. That tapered hole is probably another 8mm deeper. So there's a potential, I've had this happen a couple of times, where the filament actually kind of rolls around up in that space and blocks. This is actually my 3rd video on this subject. This is the first time I'm actually catching it before I do the modification. The other 2, if you look around for curing printer jamming disease, I show what I had done. But this is kind of what I started with before that video, in a sense, but on a later printer. So, okay, now let's pull this apart further. Now you can see there's the brass, like the printing tip. Let me just come a bit close to the camera. You see a small hole, it's probably about a 0.4mm tip. I've just put together this randomly so I've got something to handle and hold. The one that's in this machine is actually still in the machine, wired in, but I needed to have something for the camera. But this is essentially the same as all the others. Some of them have got a volcano, and some of them have got different blocks and different tips, but arbitrarily the same. So that's that. Then you've got these, well, they're called a heat break. Now this one, you can see they've got a lining tube, and they all seem to do that. I've got some stainless steel ones that don't have this lining tube, but they're not free of this trouble. I'll get a couple others. Give me a second. Okay, so I mentioned the solid stainless steel one without a liner. This is it. It's got like the clearance hole for the 1.75mm focus, 1.75mm filament. And you've got this other one. This is hard to kind of drive the camera. Bear with me. You can see it's got the smaller hole at one end, but it's got the Teflon liner the other end. Okay, but what they've done to make this heat break less conductive is they've machined off a certain amount of the metal. Now what I found is the outside diameter of that narrow section is like about 4.4mm, depending, they all vary a little bit, but in essence it's just about 4mm. Now the outside diameter of this feeder tube is also 4mm. If I hold them side by side you might be able to see what I'm talking about. There we go, focus. Basically it's the same diameter nearly. I've got away with drilling out a 4mm hole in one of these before, but it's touch and go whether it works. Okay, so let's just take out that liner. find the easiest way is just to grab a screw, wood screw. Okay, so you've got a very small, focus, very small tube, OD 3mm I think. You can see there's a bigger hole, focus. There's the bigger hole, but down the other end it's got the smaller hole for the filament to go through. Right, but what it means is we can't drill this one out. Luckily for me, this particular one doesn't have that small, that amount of the thread removed. It's the whole thread is 6mm diameter. On the other ones that are modified, I actually got some 6mm screw and just bored them out. But this one here is, its heat break is already unaffected. Might just take that liner out. If it'll come out. Will it come out? No, it's probably glued in with filament. Oh, well, you know. No, not coming out. Okay, so that'll have to bore out. Okay, now I reckon you could get away with using a cordless drill and a 4mm bit and drilling it as carefully as you can from both ends. So you meet in the middle somewhere to clear the feeder tube. I'll show you what one of those. So there's the feeder tube. A 4mm hole will clear this tube. Where are we? Here's one that I've done earlier, but I wasn't quite happy with the job I did. But basically, the purpose of that is to be able to push this tube all the way through the whole assembly. It's a bit sticky. Come on, go through. There's some obstruction there, I have to free it up a bit more. But basically the intention is to get this feeder tube to go right through. Now, these fittings have got a too small a hole for that to happen. And there's a few, let's have a look at a few more, whoops. So you can see these various fittings. They're not all the same, they vary quite a bit. But you can in fact buy them so that will clear the 4mm tube. So you can push the 4mm tube all the way through. They actually go straight through. I don't want to push it through because then I have to pull this back out again. I don't want to damage my feeder tube. I'm also going to upgrade this tube to a higher temperature tube. Can't remember the brand of it, but this one's actually got a higher temperature rating than the other Teflon. And that will allow me to bump up. I just have to change firmware so I can print a bit hotter. So things like, come on brain. Things like polycarbonate and so forth, you can print it at a higher temperature. But basically these components are what limit the temperature. So it's this little tube that goes inside the heat break, wherever it's gone, is really your temperature limit on most of the printers. This little guy can't handle like 300 degrees. And that's why they use the solid stainless steel. That's why they use a solid stainless steel heat breaks. Okay, so I'm going to go out to the lathe because I want to get a good reliable hole in here. Like I said, I think you could get away with drilling this out with a cordless drill, but I've got a lathe, so I'm going to use the lathe to just have a higher guarantee of success. This other one wasn't quite well enough done. I might also ream it out just to make sure it works properly too. Oh, there's a bit of a burr in there, that's all that is. Okay, so if we get rid of that burr, this will be a good one too. In any case, it doesn't hurt to have extra stock of these parts. They're easy enough to buy and they're cheap enough to buy, so just get stock of these parts. You can see here I've got a heap of these heat breaks, got a heap of printing tips. I've got a couple of volcanoes. Here's a volcano. So where I want to have a higher output, the volcanoes are important. This one here has not been bored out, but the heat break with that narrow section there won't allow me to do that. So this one's looking for a modification as well. I don't think I'll change over the print head on this unit to a volcano, but it's everything you do with a 3D printer is a compromise. Basically, the finer resolution you get, the slower the process is. The higher the temperature is, the more prone you are to oozing, but you get better interlayer adhesion. So at the end of the day, whatever you need to do to get the optimum thing for your printer is what you need to do for your printer. There is no best way for all of this stuff. But in any case, this blocking business, which has produced this, has a solution, and that is to overcome anywhere you've got little cavities and interfaces along this path. Anywhere you've got those little gaps and misalignments and so forth is a place that the filament, if it heats in any way, will start buckling, and once it starts it just keeps going. So we've got to eliminate that. I found the most reliable way is to get the tube to go right through everything to that brass tip. So you've got no interface layers until it hits the point where the filament actually melts, which is on that brass tip in there. Okay, let's get set up on the lathe. Okay, so let's see how that fits. You see that? So you download through it, and there we go. All right. With a bit of luck, that should go straight through. It's a little bit tightish. That's actually going in. There we go, it's coming out the other side. So as you can see, that would make contact with the brass tip. That has to be cut off square, but I actually find it's easiest to cut off square inside this tube. You can use a blade and cut it square to that line. Okay, so let's put the printer back together again and see how this thing goes. Okay, I wasn't thinking clearly. This particular one doesn't have the right thread. I must have had different ones on the last print heads. But I've used these elsewhere, say in the Bowden feeders themselves where there's a 6mm thread present. But I've forgotten I need a different size to have the 1/8 BSP thread. So I've actually put that in the lathe and reamed that out with a 5mm bit. So I've cleared, like there's a seal inside these fittings. You can probably see there's little spurs. What is there about, come on focus. Looks like about 8 or 10 spurs there, I haven't counted them. Probably 8. They're designed to clasp onto this external edge here. You can actually see where it has been clasped before. Anyhow, this tube goes through it. So let's assemble this. You can do this up tight, but it's not actually that critical. I'll use my ginormous shifting spanner here. Okay, so it's just enough to hold it. It's not really that critical. And we'll shove this tube through so that it comes out the other side. And it's going to be a bit tight. Come on, you can do it. I'll use this tube for the moment rather than... Here we go. Right, so that's out the other end. So I'll push that through so you can see this tube's come through the other end. See there's a little bit of dirt on there. I'm going to cut that off square now. I'll use perhaps a chisel might be a good tool for that. If you can sharpen a chisel, you'll find they're pretty good tools for this job. Okay, so you might have a good blade or whatever, but in any case, you try and make that as clean as you have. Oh, there's still a bit of a dag, so I'll clean it up. Okay, that's a little burr gone. That's as square as is practical for me to cut. All right, so now, when the tip from the printhead comes in into contact, fingers, when it comes into contact with that, it forms a seal within the heater block. so as to, obviously not have filament melting and oozing out the side. And it doesn't really matter if this part gets hot even all the way up to here somewhere. If there's a leak back through around this tube back up, it doesn't really matter, because somewhere halfway down here it'll solidify inside the tube and reset. Now, so this is obviously not the one that's in the printer, but I'll just show you what happens. You get to a point where those parts seat together. So the filament comes inside the guide tube, or the feeder tube, and the first interface it hits is actually the hot tip about here somewhere, and that's where it can start melting. There are no cavities and kinks or burrs or anything to catch the filament on the way through. So that should be what we need to have all done. Let's put this in and see what we get. I'm deliberately using this tube still to test that there was nothing else wrong with the way the printer's being fed. Alright, I mean that should be it. That's what usually cures it. Let's see how we go. Okay, so we've got the printer printing. I'm printing directly on the aluminium. It's done its first layer down already. It's on its second layer. It seems to be quite happily printing. Nice and solid. So we've got our bowed feeder tube going all the way back to the actual feeder motor. You might notice I've got the spool very close to the feeder, and that is because I'm getting towards the end of the spool and they get a bit tricky and unruly when you get near the end. You end up with double loops and doing weird things, but having the feeder like that means I can use up dregs of spools without it getting itself into a pickle. Yeah, now I decided to use this other fitting here so that I can use the feeder tube through that opening to go right down to where the spur wheels are. And as you can see, there's only a couple of millimeters there, which means I can get away with quite a few different compressible materials even through the Bowden feeder. So doing this modification gives you a couple of advantages. One is obviously, basically eliminating all possibility of jamming at the print head, but it also improves the efficiency or the reduced likelihood of playing up near the actual spur wheels. I've had a few, actually a couple of different printers where the filament has buckled up in this location here around the spur wheels, but by bringing the feeder tube really close to the spur wheels, you do eliminate a lot of that sort of trouble, and you can get away with a lot of flexible filaments too. Now generally flexible filaments are best used on a unit where you've got the feeder motor very close to the print head, but this actually gets around that problem quite well. If I had another one of those fittings, I probably would have fitted it on the underside here and put a little bit of the feeder tube on the lead up to it. I'll have a look. I'll show you another printer where I've actually done what I'm talking about. Okay, so this is my little G-Tech Cruiser, and we've got a very windy day here, and you can see the feeder tube going either side of that spur wheel. That works quite well, and this is actually the first one I did that way. And this machine is basically, I turn it on and print, and it just prints. It's been super reliable since I've done these modifications. You can see I've mucked around printing, making a sort of cooling fan cowls. I basically made my own print head assembly here. So this unit works really just reliably. I turn it on, give it a job to do and walk away, and it just prints it. The only thing I've got to do is maintain, I've got a PVA surface on the aluminium plate here, which I have to maintain probably every 40 or 50 prints. You see it's got a little bit of wear and tear here, but yeah, it's very easy to maintain with a PVA surface. Alright, so I guess that's it. So I'll go back to the other printer. This appears to be printing like a champion. So the proof of the pudding's in the eating, and here we are eating. Very happy. Alright, well feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.